parsing A equal B equal. So note after that operator nodes is that parsing A equal B equal C equal D equal E. For each iteration, we create a new binary expression using the previous one as the left operand. The parser falls out of the loop once it hits a token that's not an equality operator. So the parser will now fall out of the loop once it hits a token that's not equality, which is the equal. Finally, it returns the expression. Note that if the parser never encounters an equality operator, then it never enters the loop. In that case, the equality method effectively calls and returns comparison method. So because the parser wouldn't enter the loop if it never encounters the equality operator, it means that the equality method effectively calls and returns the comparison method. In that way, this method matches an equality method operator or anything of higher precedence. Moving to the next rule, we have comparison term. So for comparison, the rule will be term open parenthesis quote greater than or perpendicular bar quote greater than equal or quote less than or quote less than or equal closing parenthesis term closing parenthesis asterisk semicolon. Translated to Java, so we would add this after equality method. So private XPR comparison method, and then its body, we would define a variable XPR, capital XPR equal term method semicolon. And then next line, while parameter match with the nested parameter greater, comma greater underscore equal, comma less underscore equal, closing, and then with the body. So this is a variable token or operator. So token space operator equal previous method, and then next line semicolon, of course. Next line XPR space right equal term method semicolon. Next line XPR equal new space XPR dot binary parameter XPR comma operator comma right, closing, and then closing, then next line return XPR, then closing. So the grammar rule is virtually identical to equality, and so is the corresponding code. The only differences are the token types for the operators we match, and the method we call for the operands, now term method instead of comparison method. The remaining two binary operator rules follows the same pattern. In order of precedence, first addition and subtraction. If you wanted to do some clever Java 8, you could create a helper method for parsing a left associative series of binary operators given a list of tokens and an operand method to handle to simplify this redundant code. So here we would add after the comparison method private space XPR space term method, and then a body would be XPR space XPR equals to factor method, then semicolon. Next line is while with the parameter match parameter minus comma plus, and its body we define a variable again token space operator equal previous method semicolon. Next line XPR space right equals the factor method semicolon. Next line XPR equal new space XPR dot binary parameter XPR comma operator comma right, closing. The next line return XPR, then closing. And finally multiplication and division. So we would add this after term method. So private space XPR space factor method, and then its body, first we will define a variable again XPR space XPR equal unary method semicolon. Next line is while with the parameter match parameter slash nested parameter again slash comma star, then closing, and then inside our body is a variable again token space operator equals to previous method. The next line XPR space right equal unary method. The next line XPR equal new space XPR that binary parameter XPR comma operator comma right. Then closing. The next line return XPR closing. That's all of the binary operators parsed with correct precedence and associativity. We're rolling up the precedence hierarchy and now we've reached the unary operator. So this is the unary rule. The unary will have open parenthesis quote exclamation point or quote minus closing parenthesis unary or primary and then semicolon. So the code for this is a little different. So we would add this after the factor method. Private space XPR space unary method and a body. So instead of defining a variable and then while loop, we would start it with if with a parameter match with a nested parameter bang comma minus, and then in its body we have token, a variable token space operator equal previous method, and the next line XPR space right equal unary method, and the next line return space new space XPR that unary parameter operator comma right closing, and then next line return primary method, and then closing. Again, we look at the current token to see how to parse. If it's exclamation or minus, we must have a unary expression. In that case, we grab the token and then recursively call unary method. Again, to parse the operand. Wrap that all up in a unary expression syntax tree and we're done. The fact that the parser looks ahead at upcoming tokens to decide how to parse puts recursive descent into the category of predictive parsers. Otherwise, we must have reached the highest level of precedence, primary expression. So we will now express in Java code the primary rule. So the primary, remember, so this rule is number or string or code true or code false or code nil or open parenthesis quote expression closing parenthesis quote semicolon. Most of the cases for the rule are single terminals. So parsing is straightforward. So we would add this after unary method. Private space XPR space primary method and its body we have three if else first. So first if is if parameter match parameter with a nested parameter false. Then in the same line return space new space XPR that literal parameter false. And the next line also same line with return. So if parameter match with a nested parameter true, then return space new space XPR that literal parameter true. The next line would be if with parameter match parameter nil, then it's the same line return space new space XPR that literal parameter null. The next line, so this is the fourth if with a body. If parameter match parameter number comma string, so there's two parameter in the nested parameter, its body will return new XPR dot literal parameter previous method dot literal, then closing. And the next if parameter match parameter left underscore parent, in its body we define a variable first XPR space XPR equals expression method, and then next line consume parameter right underscore parent comma expect comma and consume parameter right underscore parent comma, and then next parameter is quote expect quote parenthesis after space expression, then closing. The next line return new XPR that grouping with the parameter XPR, then closing body. So the interesting branch is the one for handling parentheses. After we match an open parenthesis and parse the expression inside it, we must find a closing parenthesis token. If we don't, that's an error. Syntax errors. A parser really has two jobs. First, given a valid sequence of tokens, produce a corresponding syntax tree. Second, given an invalid sequence of tokens, detect any errors and tell the user about their mistakes. So, the parser is actually what gives the syntax error it got from tokens. And this is also how you would realize that a parser really check the closing parenthesis if there's an error and if the token sequences did not match the rule. So you can actually create infinite expression out of this parser using just these few rules. So aside from that is that we separated the class for this parser to follow the single responsibility principle, in which all of the phases for each of the system should be different, should be in different classes in different category. Otherwise, we will mix them up, and it's hard to evolve. So this is one of the principle of software applied. So again, these compiler are invented just so the programmer has an easier life, because they can take the burden of writing in Fortran anymore. So don't underestimate how important the second job is. So in modern IDEs and editors, the parser is constantly reparsing code. So the syntax error you would see in VS Code is actually constant parsing of the code. So often while the user is still editing it, in order to syntax highlight and support things like autocomplete. So that means it will encounter code in incomplete, half-wrong states all the time. So the second job, or given an invalid sequence of tokens, we will detect an error and then provide a mistake. So since the parser are providing the error in VS Code or under IDEs of the developer, you would the parser would get a partial state. So the problem is that how do you give an error for that? So aside from creating a valid sequence of tokens, which is the first job, how do you make sure that you provide an error? So that's a big problem as well. When the user doesn't realize the syntax is wrong, it is up to the parser to help guide them back onto the right path. The way it reports error is a large part of your language user interface. Good syntax error handling is hard. By definition, the code isn't in a well-defined state. So there's no infallible way to know what the user meant to write. The parser can't read your mind. Note, not yet at least, with the way things are going in machine learning these days. Who knows what the future will bring, of course. So this is where the AI comes in. So there are a couple of hard requirements for when the parser runs into a syntax error. A parser must first detect and report the error. If it doesn't detect the error and passes the resulting malformed syntax tree on to the interpreter, all manner of horrors may be summoned. So if it doesn't detect the error and then pass that into the string or sequence of token into the interpreter, therefore all of the things that could go wrong will go wrong. So philosophically speaking, if an error isn't detected and the interpreter runs the code, it's is it really an error? So if the error isn't detected and the interpreter runs it, is it really an error? Therefore, there's no clear interpretation of what reality is or what logical sequence of token is. Therefore, the 1 and 2 that produce a string for that sequence of token, which is the first job, and second job, which is checking the sequence of tokens and then providing the error to the user, is not a job anymore if that's the case. So avoid crashing, second job, avoid crashing or hanging. Syntax errors are a fact of life, and language tools have to be robust in face of them. Segfaulting or getting stuck in an infinite loop isn't allowed. While the source may not be valid code, it's still a valid input to the parser because users use the parser to learn what syntax is allowed.